In this clip, we're going to learn how to use hinge joints. Hinge joints are a common joint that we can use to create doors. Now, in our case, we're going to create a drawbridge. So we have our bridge. It is all connected as a single object. It has a single collider. And all we would like this to do is to hinge around a specific pivot point and then drop into position. Now in the world, I also have some colliders set up. So as you can see here, there's a collider that would stop it from swinging on through. So really quickly, let's select the drawbridge. Let's add a component, physics, and then hinge joint. By default, we should be able to just come in and hit play, and that would cause that to drop into position. So it works as we intended it. Now there are going to be some situations where you would need this to be connected to a body. So perhaps you have a door that has a door frame, and you would like that to be connected to that door frame. So in this case, we're going to use woodplank02 as kind of our frame that this is connected to. So let's drag that onto connected body. That's going to create your anchor points and automatically configure the connected anchor point. And looking at this, we have a few different parameters or properties that we can begin to modify. We have spring, motor, and limits. Let's take a look at limits first. With limits, this would allow you to limit the swing of the object, okay, around that hinge. If we were to select our ruins object and remove the box collider that is on the ground here just by turning it off, and then I hit play, what you would notice is the drawbridge go right through and then continue to swing around. So if I wanted to limit the overall swing of this object, let's say that your door can only open to a 45-degree angle or perhaps at a 90-degree angle, you can limit that by just selecting the object, going to the hinge joint, and then setting up a min and max limit. So the minimum distance is going to be set to 0. So I don't want it to go any further back than its starting position. But I do want it to swing forward to be flat with this area here. Now I'm going to show you this max distance at 90 degrees, but you're going to notice a little bit of an issue. If we hit play, and then I go to my scene, you'll notice that it's not using the limits first off, and this is a common misstep. And what is happening is that we forgot to check use limits. Now, let's take a look at another issue that typically comes up, and you'll see here that it has dropped down below my intended endpoint or intended limit. It's important to know that the value here in degrees is local to the starting position of the object itself. So you can see here that my object has a rotation of a negative 165. So I would actually want this to be at a limit of 75 if I wanted it to fall straight down. So if I hit play on this, you would see that that does drop into position right as it should. You can begin to modify this value here. So if you're not quite sure of what you need, if you wanted it to drop to perhaps not directly right on the ledge here, you can maybe make it look a little bit lower. You could always modify it like this and just say, all right, let's do 75. And then when we hit play, we'll need to make sure that we change that value. So you can always come in and get the result that you're looking for that way. Now another thing that we can do, I'm going to go ahead and set this to 75, is we can set up a value for bounciness. So let's say that I wanted this drawbridge to drop down and then bounce a little bit as it should, I think. Let's go ahead and set this to maybe a value of 0.2. Setting it to a value of 1 will create a lot of bounciness, and that's not necessarily something that I would like to see. So I'm going to go to my scene view, and you'll see that that does bounce into position. Now there is one thing that you're noticing here is that we get a little bit of jitteriness in this object. Now there are a couple of ways that we can modify that. The first one is to adjust the minimum bounce velocity, but the common way of adjusting the jitteriness is the contact distance. Let's go ahead and bump this up to maybe 0.1, and we should see this value start to come down. We could go ahead and just modify this even more. Still getting a lot of jitteriness. Let's do 0.1, and then let's restart. And I typed in 0.1, but for some reason it didn't keep. Okay, so now let's go ahead and hit play. And still getting a little bit of that. Maybe we take the minimum bounce velocity to 0.01. Okay, and there we're starting to see that that does reduce. Let's say contact distance 0.01 as well. There we go. So now if we go ahead and we modify this 0.01, perhaps the minimum distance is 0.02. And then we'd see that we reduce that jitteriness overall. Okay, so that is limits there. Now we know what brake force and brake torque are, so I'm not going to cover those. Let's go ahead and take a look at the spring and motor. So I have my limits set up, and we can continue to use those limits even if we use these other parameters as well. Let's go ahead and take a look at using the spring. Now this is going to be very much like the spring joint, and so things are going to look very familiar. Let's go ahead and set this to a value of 100, and let's leave the damper at 0 and the target position at 0. And so what we're going to see is it stay in position, okay? And you can see that it's trying to swing back and forth. So gravity is pushing down on it, but that spring is bringing it back. Now, because the target position is at 0, it's resting at the original position. So it's always trying to get back to that. If I were to modify this, let's say a little bit further, this allows it to rest a little bit lower. So I want it to always come back to its original position. So something that's really neat about this is we can create a drawbridge effect to where if I go across it, it would actually slam down and then slam back up to where you wouldn't be able to cross it. So this could be something very helpful for like puzzles or something like that. So now that we know how to use springs, let's take a look at one more, which is going to be our motor. Now on the motor, I'm going to turn off use limit and use spring. Let's expand this and say use motor. And actually, you know what? I'm going to use a separate object to display this because the drawbridge probably isn't going to be the most helpful design in this. So a motor is going to allow an object to automatically turn or apply force to itself. So this could be something like a revolving door. It could also allow you to move through an object, and we could also set it to use free spin. So I'm going to bring in just a simple prefab. I'm going to bring in perhaps this wood plank 02, and I'm going to just modify its shape to make it look kind of like some sort of door or something like that. Now I'm going to bring this up because it does have a collider on it, and that would affect things a little bit. So just be mindful of that. So now let's go ahead and tell it to not be is kinematic, and I don't want it to use gravity. And I'm going to bring in the hinge joint here. We're going to have this connected to the world, and I could use gravity here if I wanted to. It doesn't really matter because now that we have it connected to the world, it's not going to cause it to fall. So let's use our motor. Let's expand it, and you'll see that we have target velocity, which is going to adjust the overall speed of the object, and then we need to apply enough force to this that is continuous to allow it to move on its own. So in this case, I'm going to say let's do something like 100 on the target velocity, and now on the overall force, let's do something like 100 as well. So if I were to just hit play automatically, what we would see is this object rotating on its own. Now you'll see here that it's rotating around one of the pivot points. So I'm just going to move this out of the way of that collider there. And you would see this object rotating around the hinge and it's doing it automatically. Now, if I were to come in and try to pass through this, you would see that it would allow me to adjust the spin of that object. And it is going to adjust based on the force that I apply to it. Now, we could also turn on free spin, and you'll notice that this will spin much faster as I go through it. Okay, so it does pop back into the distance there. Now, let's go ahead and take the force down to 0 and the target velocity to 0. And let's turn on free spin. This is going to allow the object to stay in place, and if I move through it, then it will cause it to spin on its own. So you could do something like doors that spin, and with something like this, I could set up perhaps the limits on it. So the minimum is, let's say that it will only go back -90, and it will only go to a max of 90 on this. And if I hit play, instead of it just spinning around that in every direction, you can see that it comes back and would slam close. We could also set up some bounciness to this. So if I did 0.2, it would cause it to even come back a little bit. So now we're seeing a mixture of using these values. Now, that doesn't appear to allow it to go much further than that. So let's do 180 on the max. And let's move forward here. Let's do 90 and perhaps 0. There we go. So that allows it to open, and then it pops shut. Let's set our bounciness to 1, and let's really see this snap through. So now you can see the overall value that you get here. Now this is moving along the wrong direction. I can now see it very easily. So I'm going to set this to -90 on the max and the min. And there we go. Now let's try this. So now you can see that that opens and closes, okay, in the right way that I expected. All right, so now that we have this all set up, we know how to use the hinge joint and the different uses of it. One thing to keep in mind is it doesn't have to just be doors, but doors are a great example of using hinge joints. So now that we know how to use those, let's move on to our next clip.